Now we are told to find the velocity of the wave, given that the equation is given as this. Now we have to relate this equation to the equation of motion, which says that y equals to a sine into kx plus or minus omega t. All right, now we need to relate this to this equation. Now let us know that k here equals to 2 pi all over lambda, and our angular velocity equals to 2 pi f. So if you plug in this expression or this equation into the above equation here, you have that y equals to a sine, a is the amplitude, 2 pi all over lambda x. Then since it is minus, you have minus 2 pi f then t. Okay, now let us now connect this. You can see that this expression here equals to this expression, and this expression also equals this expression. So we can say 0.5 pi x equals to 2 pi x all over lambda, and 2 pi ft equals to 200 pi t. Now to this end, we can make f the sort of formula here. We can see that we can eliminate pi and pi from here. We can eliminate t and t from here. Then 2 here, 1, 2 in 100. Sorry, in 200 it is 100. So our f here becomes 100 hertz. And to this end, making y the lambda the sort of formula, we can now say lambda equals to 2 pi x all over 0.5 pi x. X eliminates, y eliminate each other. So at the end of the day, here we have what? 4 meter. Then we know that frequency equals to velocity times lambda, making velocity the sort of formula. We have that we have velocity over lambda rather. So velocity equals frequency times lambda, which will give us 100 times 4 to give us 400 meters per second. Thank you and God bless you.